Hello guys, day 206 I think. Let's get to the next problem. So we're doing this one. You're given n by n matrix board continuous letters x and O capture regions. Connect. A cell connected to an adjacent cell horizontally or vertically to form a region with the original one. Okay. So we have a board. Okay, so you can replace it if all the surrounding values can be I'm confused. A cell is connected to an adjacent cell horizontally or vertically, the region. To form a region, connect the region is surrounded with X. If you can connect the region with X cells and none of the regions are I'm kind of confused. we can place these with X because Y a cell is connected to an adjacent cell horizontally region. This is worded really badly. If you can connect the region with X cells and none of the regions are on the edge of board. To capture a region, replace O's and X in place with the original board. You do not need to return anything. Okay. I'm confused. To capture a surrounded region, the region is surrounded with X cells. If you cannot connect the region with X cells and none of the regions are on the edge of the boards. I actually do not understand what this is actually saying. To understand as its associated example. An O is surrounded if there is no path from its boundary of the matrix. Yes, this is very helpful. I felt the problem was difficult to understand as it and the associated example don't clearly indicate what's surrounded. An O is surrounded if there is no path from it to the boundary of the matrix when moving north, south, east, west direction. I don't really care about test cases right now. I just care what am I really trying to do. Okay. And O is surrounded if there's no path from it. Uh. Oh, okay. No path from it to the boundary of the matrix. Okay, makes sense. Makes sense. So these are not. These are surrounded because there's no path to it. In the boundary. Right? This one is not surrounded because there's a I can enter it through the I can enter it to on the boundary side, right? Okay, so then I need to do something like okay, if this, let's say this was here, right? Like this was O, then this wouldn't be surrounded because I can enter it through that. Like I think all of these would not be surrounded because I can enter it through that. But since okay, the way to do this is some kind of boundary thing, right? We have our boundaries, which are the edges of the matrix. Okay, so basically, let's say we go through and we detected O. That will be our first starting, right? And we're gonna start. Let's see, can I reach this position from a boundary, right? So that means try to get to a boundary, and yeah, and yeah. Basically, just start that, and then if it is, then replace it. If you can't get to a boundary, replace it with an X. Boom, boom, boom. If I can, then yeah, I think I got it down. So basically, we need to basically detect if we're. I think def DFS is the best way to do this. We'll take a row, call a scene, right? We'll write the algorithm a little bit later. Let's do R in range of length of board. Let me actually write some constants. So let's do row, board, length, board, call if R. Okay, so let's break this down. So we are going through the find the O and basically do DFS on the thing. So the base case is if you hit a boundary. So if RC basically, if RC, if basically if you are, no, that's not the best case. Let's do first. Let's see if you're out of bounds, right? Right. Less than 0 or R equals row or C equals column, right? Return, right? So let's get rid of that. Let's say if you are, so let's say they're inbounds, right? Let's say if you are, if I guess, are in on a, what is it? A boundary, right here. The region is not captured because it's the edge of the board. Basically, if you're on the edge of the board, right? So I guess edge. So is on the edge. How do I detect if it's on the edge? Well, if the R is on like equal to 0 or R equals row minus 1, right? Okay, let's say it's not that. It's a column based, right? Then check. Right. First, let's also get out if you are if board of R C equals an X. That means you also don't want to check that either. So, and like, right? So if we have R equals 0, okay, if we're like one of these, which is column 0 or column call minus 1. So like 0, right? Or we're on this one, right? Well, actually, hold on. Let's say column will be on this one, so that wouldn't trigger. Yeah, I think this is fine. Okay, so that means we found a valid one and it's a letter O, right? That means we should add that scene dot add RC. Also, we probably should also if prevent ourselves from probably should not check again if we're on a scene, right? Then check if you're an X. Then check if you're a boundary on the edge, right? If not, then we found probably like one of these joints, right? Add that, and then let's do the neighbors, right? Directions, we'll do this, we'll do we'll go up, so +1 0, down -1 0, 0 1, and then 0 -1, right? So for every neighbor, I guess dr dc in directions, we will do dfs at dr or r plus dr and c plus dc scene. Valid. Okay, so now once that's done, what do we return? Return true. Wait, what are we returning? What the hell? We're saying are you an edge, basically, or actually can you be accessed through? Can you access be accessed through can you be accessed through, like, are you surrounded basically? And is that the question we're asking when we call this function? Not sure. So we'll go through these stuff. Okay, basically, if I'm doing a DFS here, can I get reachable? Is this damn, I don't know what question I'm asking myself, right? Like, okay, we explore all the ways, and then basically if you return out any time earlier, I guess true. What? Let's say you hit the base case. Let's say like we hit here, right? Then no, then you're not then you are surrounded. Yeah. So we're saying we call DFS on this, right? We're gonna explore this way. Nope. We're gonna explore this way. Actually, we explore this. Nope. Then we're gonna do I think right. Then this is gonna call up. Nope. Down. Yep. And then we're gonna do up. Nope. Down. Nope. Right. Nope. So that would return true. You are surrounded. Yes. Return false. Yes. You're basically return false, right? Return true, meaning you are surrounded. Are you surrounded? If you're surrounded, then I want to do something else. So that's fine. Now for every R in range of length or row, for every C in range of call, board. I guess we can say, alright, so DFS at RC, and we'll say, we'll call this set here, right? And then we'll call this S here. If true, then board of RC equals X. Otherwise, yeah. Whoa. Wherever is in range as if DFS RC. Yeah. Okay. I don't think this is gonna work. Oh my goodness. Is there an edge case that I did not consider? Maybe. Or is this too slow? Possibly. How big is this? Board dot length, end dot length. Not that big, but yeah, we got a wrong answer, brother. Okay. What? Oh yeah, that should have. Wait. I'm confused. We're given this input. Okay, use this test case. Oh my god, so it's more generic. Oh, wait, what? Wait, what is the expected output for this? Oh yeah, it shouldn't change anything. None of these should be changed to X because they can be accessed. Wait, what? Oh wait, that's actually really weird. Hold on. I see. Oh. Let me see something. Let me cook. Oh, okay, I know the issue. So this should return nothing because you can access any of the O's because the edges are like accessible, right? I think my output was, I changed it to X because I think when I get to this one right here, right? When I get to here, I call DFS, right? And I'm gonna go, let's start it. Let's start the thing. So let me check 0, 1, 2. Yeah, this is 0, 1, 1, 1, 1, 1, 1. Nope, doesn't enter that. Nope, this is the first time we're seeing this. Is this equal to X? Nope. Is this equal to a boundary? Nope. Is this equal? Nope. So let's add that 1, 1. So we have 1, 1 in our thing, right? So we have 1, 1. So 1, 1 here. That's in our visited. Then we're gonna call our neighbors. So let's go. I'm gonna put this test case up here. Okay, so we're gonna go up. That should have been a false, and we should have ended it. Oh, I think I messed up. I see the issue. I think I see the issue, guys. Because now I call this. This would be false. Going here would be false, and then I finish everything and then return true. That's not my. That's my problem. I need to return if. Okay, that's why I shouldn't do this. Up, down. I gotta rethink this. So let's do up, down, equals DFS R plus 1, C and S, down, left, right, and then this will be any of these are true, up or down or left or right. Something like that. And then okay, so let's go down. So that should be -1. Left should be -1. Yep. Right should be +1 or plus C. And yeah, so because as soon as I went up and I would hit this one, return false. Go down, I would have returned false. Left would also return false. Right would be for return false. So all of these return false, therefore returning false. Oh my god, no. Now the first one's being weird. So the first one here, let's see what's wrong. So this is okay, so we have this xxx. Oh, okay, that's valid. So our output was, oh, I see. See, okay, now I got the logic flipped. I should be able to, this, I try to go anywhere else, right? Basically, if, oh my god, hold on. That's bad, hold on. This logic here is pissing me off. If DFS R, C, and set, right? Okay. Basically, when I call you, what do I really mean? Like, what do I want to find? Are you surrounded? Meaning, yeah, like, are you surrounded? So, so like when I call you, I cannot reach you from the boundaries. So for example, so 0, 0. Okay, so okay, here we didn't get This one wasn't valid because, okay, I will go up. No, that's false. I will go right. Wait, hold on. This doesn't make sense. I'm always going to return false. Okay, then I'm going to return true. I should return true here, right? Right? If you're a boundary, return true. Why? Let me cook here. So if you're a boundary, right, then like for this one example, this will return true because it will hit at least the C will be a hit, right? We'll be on we'll be on the row. We'll be on the row equals row minus 1 will get triggered and that will return true, right? Meaning when we right, we'll check itself and then that will return true. So this will be you are accessible from the thing, from a boundary. So that's what I'm looking for. So if DFS is true, that means you're basically is not, I gotta write it more descriptive here, right? So we have this here, right? If is can reach, right? If no, cannot reach, right? Then you change it. If you can reach it from the edge, then don't change it because that's what we don't want, right? So yeah. Please, bro, just give it to me. Please just give it to me, bro. Please. Please, bro. Please, bro. Please. Oh my god, why is it taking so long, bro? What? Are you kidding me? I got TLE, bro. Oh my god, bro. This is not efficient. Damn. That sucks, bro. Okay. So what can I do to optimize? I don't know. I give up, guys. I was close, bro. Are you serious, bro? That's some bullcrap, bro. I got a Tealy on the one last pawn. Bye. Yeah. Instead of calling it for every single one, you should call it on each row once, each column once, and then see the intersection. I think that's what it is. Okay, I think I have an idea. We can optimize this by calling it, I guess, like more strategically. So for every we'll have this. Let's do a row set, right? And then we'll call this call set, right? So for every I in range of length of, or we could just say row. We can say R here, and we'll call DFS on row. Right. So DFS on all the rows, which is going to be, right, we have RCS, or I think we can do, okay, I see. All the rows. Then, okay, so I don't have C, so I have to do something more strategic. I know I have to put the row set, so let's put that. And we'll do this, right? Okay, yeah. So I think it just stays stagnant. So 0. For every C in range of call can reach, we will do DFS at C to 0, or it'll be to C, and call set. Well, I think we're missing one more though, which is this row. Not really. What? These here. Wait, so we have to do this one here, right? So the first one's gonna do this one, this one, this one, this one. And I also should need to do this one, this one, this one, or this one, or so okay, both of them have to do something else. So I see the issue. Okay, so then I just call this call 1, call 2. We want this one. This will be covered. Oh God, this is super hard. So we have this. So okay, what I'm doing right now is covering this. This one's gonna just cover all the C's, which is gonna be all of these, right? Oh, actually, all of these. So we only covered these two. Now I need to cover this and this. So I should call it row again. Call 2, which is DFS at row minus 1. And no, it's still going to be row, and then but at the call minus 1, yeah. Set Okay, now I can do the same thing, which is gonna be call 1, call 2. So the column is going to do, it's going to be the same as this one that's covered. Now I need to do C and then row -1, because yeah, basically all of these. Yes. So then for every chord in list of, I guess, hold on, let me just print row set and col set. Let me just see what that does. Oh my god, no, that's not good. There's nothing in common between the two. That's so annoying. Where's DFS? You know what I realized? This is pretty redundant. Because actually it's not. Bro, I swear I kind of did this. No, this is what I'm not trying to do. Okay. Okay, I think I know why I'm missing this. It's literally because I'm gonna copy this. Basically, I should mark it as safe. So like, low key, these are not necessary, right? So board divide, like I don't even need a set, to be honest, right? Okay, so we got up, down. I don't even need this, to be honest, as well. Right? Just call them and then just mark it as safe, right? If we are less than 0 or equal to column and the board doesn't equal or board I or R C does not equal O. Right? Oh my god. Right? Otherwise, mark it as T. Right? Or let's just put this because that's what he did. Because then when we do the iteration, right? 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 We have this going on, and then we do it. How is this more efficient than? That's super annoying. If board of I or R C equals this, board of R C X else elif board of R C equals pound, then board of R C equals O. So basically, we don't want to call the DFS. Man, I could have adjusted that then. My logic would have been fine. Basically, just don't call DFS if it's safe. But how would you do that? It's just better to do it while you do traversing and stuff, right? That sucks, really. Okay, maybe it's my let me just see if this is working. So first let me do if we're calling them correctly. DFS board I basically R wait. Basically R 0 and then R colon, so yeah. Then calls 0 to C and row minus 1 C. Okay, that's right. Yeah, I'm doing this right. I guess we could do this too. If O equals 0 or call equals 0. Alright, how is this not working? Explain to me. What? What are you talking about? Oh. I'm I'm so confused. Oh my god, bro. What? Why are those lingering? Or row R equals C. Or border of RC does not equal the 0, then return. Then do that. Oh my god, I see why. Because the state of the board changes every time. Okay, it makes sense. So that's why I have to save the state of the board. Wait, that doesn't make sense. The board is gonna stay there like no matter what. What the fuck am I talking about? What am I missing here? Throw if min C equals call or board RC does not equal 0. Alright, I think I'll figure it out later. One more try. What am I? Why is it not overriding if board over equals the pound symbol? Yeah. XO. Oh my god, I think I got it flipped. If it's basically, okay, if you're a pound, if you're an O, you should change it to an X, and then if you're a pound, you should change it to an O. Okay. Wait, so I had that right, okay. Alright, I'll figure it out later. Thanks for watching. I'll see you tomorrow. Peace.